Yeah, today we're going to finish up comparing two proportions. We've done confidence intervals, and this time we're going to talk about how to do a hypothesis test to compare two proportions. So the test we're going to do is called a two-proportion z-test. We've done one proportion z-test. We've done one proportion confidence intervals, one proportion or two proportion confidence intervals or z-intervals. So now a two-proportion z-test. So our null hypothesis for a test like this is going to be that there is no difference in the proportions from our two groups. So our proportion from group 1 minus the proportion from group 2 is going to be equal to 0. That's our null hypothesis when doing a two-proportion z-test to compare two proportions. We have to calculate p hat, though, in a different way. We need to what they call pool the successes to calculate one p hat. So we're not using two different p hats. If we're calculating a standard error using two different p hats, that kind of contradicts our null hypothesis that the two p hats are equal and there's no difference. So what we do is we take the successes from each group and add them together and divide them by the total number sampled in each group. So we sort of get one combined number of successes and one combined number of people or things sampled, and we find one p hat that we called a pooled p hat. And so when we calculate our standard error, we use the p hat pooled value, and we find a q hat pooled value just by subtracting our p hat pooled from 1. And in our calculation, we're going to use both of those numbers twice. So the numerator of each of these fractions is p hat pooled times q hat pooled. So the same value. And then we divide each, one by the sample size for one and one by the sample size for the second one. And that gives us the standard error for our difference in our two proportions. And then finally, we're going to calculate a z so that we can find a p-value, a probability. And so since our assumption is that there's no difference, 0 goes here where the mean would normally go. That comes from our null hypothesis. There's no difference, 0. And then we're actually going to calculate the actual difference between the two sample proportions. And then, of course, we'll use our standard error from the pooled standard error that we would have calculated before. So let's put this into practice. Again, the process is very similar to what we've done for one proportion. Assumptions and conditions are very similar. We've got to be a little bit, we've got to find a little bit more information here because we have two groups. So take a second and read this. I've adapted this from the book, and then we'll do a hypothesis test together. So we have this sleep foundation, and they're trying to figure out stuff about people's sleep habits, and specifically they asked a question about snoring habits. And so they broke the group of people up into people who were under 30 and people who were 30 and over. And so they wanted to see if there's a difference in sleeping habits between younger and older adults. And so they found that 26.1% of the 184 under 30 snored, and 39.2% of the 811 over 30 snored. And so what we want to know, are the sample differences an indication of a significant statistical difference in the age groups and whether or not they snore? So we need to check some assumptions and conditions, of course. One thing we need to know is that the two groups are independent of each other. So the young people snoring doesn't affect the old people snoring, and I think we can assume that that's true. Both groups need to be randomly sampled. In the problem it says they were randomly sampled, so we're good there. We need to check that both groups represent less than 10% of their population. And so the 184 under 30 and the 811 30 and over, they're definitely less than 10% of those categories in the United States. And of course, we need to check NP and NQ for both groups. I did a little rounding. So I multiply that 0.261 times 184, and then subtract what's left over, and then same thing for the older people. So we're good to go on NP and NQ. And so now we can start with our hypothesis test. So we write our hypotheses. Remember, like I said in the last slide, our null hypothesis is going to be that the difference between the two groups is 0. There's no difference. They're the same. And our alternative here is going to be that they're not the same. So not equal to 0. The difference between them will be not equal to 0. And we'll use a 0.05 significance level since we weren't asked to use anything different. So now comes the calculating. Calculate our p-hat pooled. So I'm going to take the two NPs, my two success values for my old and my young, and add them together. And then take my two sample sizes and add them together. And then I take a value of 0.3678 approximately, and that's our p-hat pooled. So that's our combined p-hat basically. And then we'll calculate the standard error. So if I subtract this p-hat pooled from 1, I get q-hat pooled, which is 0.6322. And I multiply both of those in the numerator of both of these fractions. Divide each of them, 1 by the 811 older people, 1 by the 184 younger people. Add those two results together, take the square root, and get a standard error for my pooled sample of approximately 0.0394. And so I've got one last thing to do before I get a z-score, and that is to calculate the actual difference in the proportions. So I take the actual p-hat for the old and the actual p-hat for the young, and I subtract them, and I get 0.31. And I'm doing the big one minus the small one here to get a positive value, to get a positive difference. And what this shows is right now from our samples, the older people have a higher rate of snoring. So now I'll calculate a z and a p. For my z, I use that p-hat difference, the one I calculated just then, old minus young. I subtract 0 because our null hypothesis is that the difference is 0. Divide by your standard error pooled and get a z-score of 3.32. So it seems pretty unusual that we've got a sample difference of 0.131 based on our z-score of 3.32. 3.32 standard deviations above 0 is pretty significantly far. Nevertheless, we'll calculate a p-value. This is a two-tailed test because our our alternative was a not equals to, and so we're gonna find this area in the right tail by doing our second vars, normal CDF. Our lower bound is going to be 3.32, our z-score. Upper bound 1e99, and then we'll multiply that p-value by 2 to grab onto this left tail, and finally get a p-value of close to 0.0009. Very small. We could have guessed that by the z-score being so large. So we have a very small p-value. Hopefully we know by now that the p-value is much smaller than alpha, 0.05, and so we're going to reject the null hypothesis, and we're going to conclude that there's significant evidence of a difference between the age groups. And I wrote a conclusion up here. So there's a significant evidence to show that there's a difference in snoring rates between older and younger adults. And since we subtracted the older minus the younger, we can conclude that it appears the older adults snore more than the younger. So again, the process is very similar to what we've done. Check conditions, write hypotheses, make sure you do the calculations correctly, and then of course you have to make the correct choice of reject or fail to reject, and write your conclusion up correctly. Making sure always to state your p-value, significance level, and then what that is it means. So make sure you bring any questions you have to class. We'll do some of these together. We'll work on this together. See you then.